They don't solve everything. Just like code, you can write really horrible tests that aren't readable and might have bugs. So I've seen lots of tests in our code bases that they look great and whatever, but then you realize that they have some misconfiguration and they're not actually running at all. So buggy test frameworks, they also have maintenance costs because when you change the behavior of your code, you have to go back and change your tests. So this has varying degrees of maintainability issues, in part, or costs, depending on the style of your test. And then also I think it's important to talk about why we're interested in talking about testing in general. So one of those reasons is the Clojure community has the REPL, right? And so we've been doing testing for a long time in various communities, but I think the REPL really changes how we do testing in Clojure. And this is because instead of using unit tests and TDD and all that, you can really just spin up your code in a REPL and try it out. So this means that there are lots of people that you talk to them about testing in Clojure, and they don't actually write tests. They just play around with it in the REPL and ship it over to their source code. But this also means that you have different types of test frameworks. You'll have like Clojure tests, which is very minimal. It doesn't give you many tools, but you go and you have to plug in things from there. And then you have other frameworks like Midje, which are very powerful and expressive, but also complex and scary. And then the second thing is Nubank has been working on their testing approach for a long time internally, and we'd like to take the time to share what we have with the community and see what you guys think. And so before we talk about the ways that we test, I think it's important to talk about what we test. So all of our microservices at Nubank take the ports and adapters structure, also called the hexagonal architecture. And the idea of this is at the center of this, you have your logic, right, which is going to have all your pure business logic. It shouldn't raise any exceptions. It shouldn't do any I/O. It should take in pure values and return, likewise, pure values. But of course, you can't live in that world forever. So you need to have your controllers, which are the glue, which coordinate calls between this pure logic and the logic, and like input and output, hitting the DB, doing HTTP calls, and producing messages to Kafka and whatnot. And before you take in messages from that outside world, you need to be able to adapt them to your internal data representation. So that's what the adapter level does. And so the controllers will use the adapter level to protect the offer like a buffer between changes of the external world and the internal world. So whenever something changes in the external world, all you need to do is go to the adapter level, know exactly where to look, and update your adapters. And then on the outer level, we have our ports, which is where our I/O happens, where we do HTTP calls, and so on. And these ports, at Nubank, we organize them as components. So there's this components abstraction that Stuart Sierra has, this library that's nice, and it's a way of encapsulating immutable state and doing dependencies between various pieces of immutable state. So for instance, our HTTP client might have to spin up some state, and it might depend on some configurations that also have state. And so when you spin up the entire HTTP server that makes use of this client and whatnot, it'll start up all the dependencies in succession. So for the rest of the talk, I'm going to be talking about the different levels of testing that we use. So this shouldn't be a surprise, but I think that we structure things in a particular way. So we have unit, integration, and end-to-end. So let's start with unit tests. And when I'm talking about unit tests, I'm talking about you call a very specific piece of code, call a function with passing in all the arguments and test the results explicitly. And that function is, of course, going to make calls to other parts of this microservice that you may or may not have implemented already. So to give an example, in particular, because we use Midje, we made that decision at the beginning. So I want to sort of go over the Midje syntax really quickly because it's a little bit different. And examples in the rest of the talk will depend on it. So say we're in the logic namespace of some example microservice, and we have a new account function. It's going to take in a customer ID my customer name. And then it's going to generate an account ID and return the name and the customer ID in there with some tags that I've hard-coded. If we want to write a test with this in Midje, we have in our test namespace, we have a fact. Oh, by the way, can you guys read this with, I think I can do this weird thing. Is this better? Yeah. Sorry, this is also why I'm like looking at the screens inside of my computer, because the only way I can get this is if I turn the screen off on my computer. Anyways, cool. So the idea here is you have a fact, and then you can have some checks inside of your fact, right? So this is similar to like the def test with the is enclosure test. And a check is going to have the expression you're evaluating, an arrow, and then the result that you expect. And in this case, so we're calling the new account with the customer ID that we generated here and some customer name. And then on the right-hand side, we expect to get back the map, but we've wrapped it in this just checker, which is a Midje construct to give some more expressiveness of exactly what we're checking here. So we say we want just this map that has exactly these keys, and if it has base values, it's going to compare them with normal equality. But if you have like predicates like UUID or sequential, it's actually going to take the value at ID that comes out of this new account and run the predicate over it. So it gives you a little bit more expressibility, so you don't have to actually like check those by hand. You write down the data structure you want, and you put the predicates in there, and Midje will run the checking for you. So hopefully pretty straightforward. And then if we want to do something a little bit more complex, say we want to write a test for the controller, which is going to, at the controller namespace where we have create account, it's going to take in the customer ID and then the storage and HTTP components. So the storage is just, we can think of it as like in-memory storage. HTTP client component allows us to make calls to other services. So if you look here, I'm calling, with all that input, I'm going to call get customer to get some information about the customer. And then I'm going to pass that information into the logic layer that creates the new account, right? So here in this get customer, I'm going to actually make an HTTP call because I'm passing in the HTTP client. And then I'll store it in the DB level and return the account. So to expand the implementation a little bit more, we have the get customer thing, which actually just makes the HTTP call. And say I want to start testing this using, before I've like really implemented a mock for HTTP client. I don't want to spin up all the state for the storage and all that. I just kind of want to get some code coverage before to make sure that everything's running fine. So the way that we would do this with Midje is we say, okay, I'm going to call create account inside of this fact. I'm going to pass in the customer ID, but I'm going to pass in these placeholders and that are like dot storage dot and so on. And they're called meta constants in Midje, and it's just sort of like a way of saying like I don't actually care what this is. It's just a placeholder. But obviously, when you actually start running this code, right, the create account is going to try and call things on this placeholder for HTTP, and then it's going to crash. So what we need to do is we need to say, whenever you try and like run a placeholder thing, so for instance, whenever I try and call get customer with this HTTP client placeholder and the exact customer ID, don't actually run the code, just return this body. So this is a really expressive way of doing stubbing of functions. Where you can say, like, only stub it out if it's called with these exact arguments. And the same can happen for add account, where in this case we don't actually care about changing the state of the database. We just say pretend it made the, or make sure it makes the call, but I don't care what comes back from it. Cool. And then another interesting thing is that the thing that we're checking here on the right-hand side, you'll see that we have a just checker, and then inside we have another nested one here. Because when you have nested data structures, you have to nest these checkers. So with that, is this okay, or should I leave it at the? Yeah. Okay, cool. With that unit tests, you can see in that controller test that we didn't actually test very much logic. It was kind of just saying that, oh, the arguments that came into this create account controller, we made sure that they were passed to the correct like downstream functions. So we weren't really testing that much code at the controller level. But at the logic level, we were able to get some more like the functionality is actually doing something. We're able to test that. So the pros that we've the pros and cons that we've sort of established at Nubank is that unit tests are really good for quick iteration because you can stub things out and really get some coverage of like new code that you're writing. And that means they're lightweight. You don't have to spin up a bunch of state and stuff. And they're good for testing pure logic. But then if you actually go back and start changing your code, all of those stubs that you put in are going to get in the way, and you're going to have to update all of these controller level tests, and it can get really cluttered. So what we try and do is we try and keep our unit tests to just pure logic. We have a couple of controller tests like in our new services, but like every time you go and like mess with an old service that like had a bunch of controller level tests, like hundreds of tests break, and it's horrible and a pain. So we're trying to avoid that now. Yeah. So with that, before we jump into integration tests, I just want to highlight a couple of other testing constructs that we use that are helpful, that we use throughout unit and integration and whatnot. So the first one is tabular. Tabular is similar to Clojure tests R construct. And what it does is when you have a check, you can actually run it several times, picking from a table of values. So it's a good way of just like enumerating all the possibilities of like inputs and outputs. So a concise way of doing that. Another one is we've started doing more generative testing. And when you do generative testing, you kind of have to wire a bunch of library calls together and hook it all up, which when you get used to it, it's not a big deal, but when you're starting out, it's like hard to remember all the time. So what we did is we extended Midje to have this for all construct, which will do a lot of that for you and take care of the binding of the generators and running the body, and give you a pre-printed result if it fails with like the shrinked failure case and all that, and like the seed information. And then the last thing is, since we're testing microservices and like what's coming back from HTTP endpoints, we have like these big nested data structures that are coming out of that we're checking against. And so when you annotate, when you use Midje checkers and you have to like put the just or the contains and all that at every single level of the nested data structure, it becomes pretty overbearing. So we developed this like implementation of a recursive version of Midje checkers, but it ran into some issues of printing nice diffs. So it motivated us to develop this new library, which I'm going to demo now, which is called matcher-combinators, which is a nice way of checking nested data structures. So now for the first part of the demo. And since I don't have my screen here, I'll put it up there. Cool. All right, so let's just take, for an example, that we have some functionality called approved customers, which if it was real code, it would be doing a bunch of stuff to generate this output, right? And what it's doing is it's generating some HTTP response that has a body that is going to return 2 customers, but the order doesn't matter. Every other time you call it, it's going to come back in a different order. So if you wanted to test this in something like Clojure test, you'd probably build some like helper methods that grab out elements and check that they're there and whatnot, so you have some boilerplate to do. And if you want to check it in Midje, you can use the checkers, but you run into some issues. Cool. So for instance, this is how I write the check in Midje. You say run approved customers, use the contains checker, which is going to say it has at least these 2 keys. It can have other stuff. Like I don't really care about what the header is, so I don't want to assert any behavior about it. But I do want to say that the body has these 2 entries. They can be in any order, and in them they have 2 customers, Alice and Bob. Right, so when I run this, everything passes, it's fine. But then if I decide that actually I don't want to get a customer named Bob, I want some other name, right? The result I get back from the checker says, you passed in this map, or this was the map that was the actual result, and it just didn't check, or it didn't find a match. So you don't really get very much information back, and really all the information is there to show a really nice diff of like what the exact difference was between the expected output and the actual output, but the checkers aren't really smart enough about passing back that diff or trickling it up to the top level checker so that it can do some nice pretty printing. So what we did is we tried to implement a new system, which is called matcher-combinators. And so when I say matcher-combinators, you can think about like combinators in the like Haskell parsec, parser combinator library sense. You have like base parsers and combinators to build them up. And so here we have base matchers and then ways of combining them into more expressive matchers. So in this case, we say we run improved customers and we do a match. And you can essentially write the data structure that you want to get back. And by default, when the match construct sees a map inside of it, it's going to treat it as it contains in the Midje checker behavior. So it says, I want at least these two keys, but I can have more keys, because generally you just want to do loose matching when you're dealing with maps. And then with lists, it'll take the strict interpretation and say, I want exactly these elements. But you can actually override it and say, I want exactly these elements, but they can be in any order. So you use the in any order matcher combinator. So when you do this, let's see. Right. Change the name. This is one that's not Bob. What I get back is something saying, like Midje returns the normal thing it always returns when it fails. We'll ignore that. But what you get back from the matcher-combinators library is this thing saying, you got a mismatch, and this is the thing that you passed in, but there was a mismatch exactly at this point, where it has, like this is the thing that you expected, and you got someone that's actually not Bob as the result. And you can do this, and it's pretty expressive, so if I decide to take out this any order thing, right, and I run that, it'll say, like, I was expecting as the first thing to get back Alice, but you gave me Bob, and then the second result was another mismatch where you gave me Bob, but I expected Alice. Cool. And I jumped a couple of steps because the parser of the matcher combinators actually has default, like by default, it assumes that a map is going to be treated as like an embeds or something that may have more keys, and like base values, for instance, like a string, are going to be used use the equals matcher. So this is the super explicit version where you're not letting the parser make any decisions about how you're going to match different types of values. And then, since not everybody uses Midje, we wanted to make sure that this library, which has nice diff pretty printing, is applicable to everybody. We took the time to actually make it work with Clojure test. So we extended the is macro to have this match construct. And the match construct, you're going to pass in the same type of like matcher combinator thing, where you can have maps or you can have matcher combinators, and the parser will do all the work for you. So when this fails, you get back the exact same type of thing that you can use it across test frameworks. So you're not constrained to just use it with Midje. And then to drive it home a little bit, like before in Midje, when you wanted to check that you have like a list of a list of a list with one entry that's odd, you would have to write this big thing. But with matcher combinators, it'll assume that you want exactly those values. You don't have to actually annotate every level, and you get back to the, it'll have the same behavior, but it'll give you a nicer output. So for instance here, if I say even, what it's going to tell you is it's going to say, inside of this list of a list of a list, we have a predicate that we're checking. We passed it 1, and it didn't pass for the even predicate. So you get a bit more information than just this didn't satisfy the checker. And so the same thing for like maps with Midje, you would have to do a bunch of contains. With the match construct, you don't have to do that. But of course, you don't win every time, because if you want to go against the defaults of the parser that we've set up, say you want to say this map has exactly only this key, you have to put like the equals around every single thing. So it doesn't win every time, or you can't win every time. Cool. So now on to integration tests. So there are lots of different ways of, or like integration tests mean a lot of different things. So in our case, we're concerned about testing an entire business logic flow. And it's at the granularity of a single service, so we don't want to have interactions with anything else. But we want to leave the code inside of the service unmocked and just do mocking at the ports level. So like for HTTP or PubSub and stuff like that. And we're interested in running code in the service or triggering the code only at the service boundaries. So you'll hit like the service with an HTTP request, and that will run a bunch of code, produce outgoing Kafka messages, and then eventually respond to the HTTP request, and you can assert on those outgoing messages or the values that were returned. So that's the form that they take, but we wanted to write them in a very particular way. So since we have so many engineers, it's important for us to have a very uniform style, and so we decided to force people into the box of doing a linear progression of steps, where each step is either an effectful transition or an assertion over the state of a world world. So you're transitioning from one world state to another and asserting things over that world. So we get uniformity. Engineers can change teams and understand what's going on because we have this uniformity. And then we're actually able to use this structure of like taking steps of world transitions to do our end-to-end tests. So what does that look like exactly in Nubank? An example of what we ended up with. So what we ended up with is a macro, the flow macro, which is a world transition system where you do these effectful steps or checks on them. So for instance, you start with an empty world at the beginning of the flow, and this empty world is an empty map, and then you're going to initialize some state. So in this case, like we need to spin up all the components that are needed to run the service, but we do so in the list of the function. So when we do the initialization, we take in a world, which in this case is empty because this is the first thing in the flow. And we're going to spin up all of the components in the microservice, so like the HTTP client, the DB, and all that stuff. But we're going to do it for the test environment, right? So we'll have injected some mocks in there, so we'll have a mocked HTTP client and whatnot. And so we clear the state of any of those components, and we put the result of the system into the world under the system key, so that we can access it later if we need to use it. So with that, we can jump to our, so the output of the init function is going to return a world with a system in it, the system key. And then since we're trying to create a savings account, for instance, we're going to generate a customer ID to associate with that savings account. So we have this function that takes in the world and it soaks a customer ID into it so we can access it later. And then before we create an account, we might want to check that there actually is not already an existing account under that customer ID. So we take in, so this is the lookup function that takes in the world. It's going to grab the customer ID out of it, and it's going to build a URL to hit the service that we're testing, and make sure that there isn't actually an account for the customer ID. And then we put the result back into the world so we can check it later. So in this case, the next step isn't a transition, it's a check over the state of the world, and we just make sure that the thing that we got back from the lookup is an empty map. And then the next thing we want to do is actually hit the create account endpoint. And so if you remember from the controller level test, we were actually making a call out to another service, right? And since we're only concerned about testing at the single service level, we need to mock that call. So in this create account, we're going to build a URL that is for the outgoing, or the service that gives back customer information, and then also the account creation URL. And we say, when we post to the create a new account, if we ever see any outgoing messages, outgoing HTTP calls that match this customer URL, give back this body, right? And if you don't see any, throw an error because we expect to see that call. So this is a way of doing mocking at the boundary level of the service, and say anything going out, we can replace with this response. So we do the call, it's going to run a bunch of logic in our service and give us back a result that we put back into the world, and then we can assert things over it. So in this case, we have this fact that is going to grab the thing that came back from hitting the account creation endpoint, and so we can run the tests, and it passes. But of course, if you change something like, actually I was expecting a string here, we're going to get back something that says, everything matched except for in the customer ID, like the UUID I got back is not actually a string. So that's the structure of our integration tests take. And what we found through years of doing this is that it tends to be the heavy lifter for our testing suite, essentially, because you get a lot of code coverage because you're not actually stubbing out any functions. And since you're not stubbing anything out, you can turn on schema validation. So we generally tend to annotate our functions with schemata schemas to check input and output. We don't turn that on for unit tests because they do all the stubbing and that makes them fail. So we turn it on by default for our flow tests. And then since we have a linear sequence of steps, it's fairly readable because we've hidden a lot of the complexities into these helpers. So we try and make the flows be readable, and so it acts in some sense as documentation. All right, and so lastly, we do our end-to-end tests. So since we have over 200 services running in production, how do you change, or how do you check that any changes aren't going to disrupt interactions between them, right? So back in the day, we were actually testing things by hand. We would spin them up locally or deploy them and make sure that everything was working. And this wasn't scaling. So what we decided to do is make a copy of our entire production stack, and then run tests over them by running flows that are going to actually hit services that are in this end-to-end stack. And so this gave us a lot of confidence in the early years. And currently, what it looks like is we're only testing happy paths. Because we have so many services and so many things to test, we don't want to take the time to test failures. So we're only doing happy path stuff. And it takes 15 minutes to run this test suite. And so any deployment or any changes deployed to the new service are going to have to go through this. So it can actually be a bottleneck if you have a bunch of engineers trying to ship at 4 p.m. and then they want to go home. And so it can cause a lot of anxiety, some anxiety because of this. And if you don't write a test that takes into consideration timeouts and retries and stuff like that, you can get some flaky tests in your end-to-end suite. And so as time goes on, we're finding that though it gave us a lot of confidence in the early years, we want to get some more lightweight verification tools that don't cause these bottlenecks and maintenance burden. So the idea is, and so we started investigating what does E2E actually catch these days? And we found out that most of the time it's just people forgetting to update their tests, their end-to-end tests when they deploy behavioral changes to the services. And so the failures that are happening are not actually helping us catch bugs, they're just telling us that our tests are out of date for the most part. And most of the value we get these days is when you start up a new microservice and you want to put it into production, you write E2E tests, and this gives you some visibility into how it would interact with other services. But once you get past that hurdle, it's not actually catching many bugs. So the idea is to have some new tools that are more lightweight that you can mix and match to give our teams more flexibility and not have to go through waiting all this time every time they want to deploy changes. So the two things that we're currently investigating are consumer-driven contracts, which is sort of the hype when you look at testing at the service system level these days. And the second one is doing validation of cross-service communication by generative testing of schemas. So if you say you want to hit an endpoint at another service and it has an input schema, and so you can generate some examples. I always mix these up, but essentially it's you generate examples of data at the endpoints and make sure that like the producer, what comes out of the producer can be consumed by consumers before you deploy it. So you do this statically by, we have a line plugin that goes in and generates these and then posts them somewhere so you can validate that you haven't broken any schemas before deploying. Good. So to wrap up, unit tests we find are pretty good for pure logic and iterating on code, but we try and avoid them as much as possible and defer to integration tests because they have a higher maintenance burden. And then our integration tests, which take this sort of constrained flow pattern, are the workhorse at Nubank. If you're trying to debug something where you set up some state and set up conditions and then you hit the error, generally you can reproduce it with these integration tests. And we also share the mocks across the whole organization. So we have some mocks that we've refined over time, and they mirror well enough production components. And then cross-service testing is difficult. It takes an investment. We got a lot of value out of E2 in the beginning, but now we're looking for more lightweight tools. So with that, thank you. And here's some links to GitHub repositories that we work on. So since we use Midje for like all of our testing levels, we use it for unit integration and end-to-end, we tend to find some bugs on it. So we actually took over maintenance of that. So I'd be very curious to hear what you guys think of it, if you have issues with it or whatnot, because we're trying to make it better as we encounter issues. And then also there's this matcher-combinators library that we just put out a couple of weeks ago. So I'd be anxious to get some eyes on that to see what people think. And then the flow macro we put in this repository is salvage, so people can take a look and see if it's useful for them. And then all of this, all these things together in play, I made a little basic microservices example to really show how it all hooks together. It's pretty simplistic, but it shows how we use pedestal with some interceptors to put the components into make the components accessible to like HTTP handlers and whatnot. So if you're curious and my examples didn't make enough sense, take a look at that. And then of course, we just opened up in Berlin and are looking for Clojure enthusiasts. So if you're interested, be sure to drop us a line. Thanks.
Thank you, Philip. And sorry for the
No worries.
wait stuff happening in between. Hello. Yeah. So we have 5 minutes for questions. Start from Josh.
Thanks a lot for the talk, really nice. So about unit tests, you said they have high value in the beginning, but then kind of get in the way.
Yeah.
Have you found yourselves actually deleting them?
Yeah.
Okay.
Yeah. Definitely.
Awesome.
Mostly because back in the day we did a lot more of them, and now whenever I see them and it's just like, oh, we're only validating the flow of arguments to lower level functions, like it's not. If that code is covered in the integration test, just rip it out.
Okay, yeah, I mean, with the REPL, a lot of times I kind of do REPL-y stuff and then I paste it in a test file, and then at some point I wonder, why am I doing that? And so, okay, thank you.
Yeah.
So a very opinionated question.
Yeah.
Do you use the special powers of Datomic to for your flow testing, like the ability to fork, the ability to treat it as immutable values?
So I actually don't know that much about that area. So we do we can set the time of the worlds or the database. So if there are any timing tests that we need to do, we can sort of do time travel with the database, which helps. I don't know if anybody wants to jump in on that because I don't have much context.
Yeah, so we don't do that much datomic time magic unless we're using it, actually that's the way we're using it in production. There's no like really special testing thing, but with datomic, testing the database layer is really nice and there's some magic there. But for the integration test, just having a datomic in memory that behaves just like datomic in production is really good. So we don't mock it, we don't stub it, we just use the in-memory datomic component like a normal database and it works well.
I was wondering if you deploy automatically to production after the end-to-end tests, or the production deployment happens before, just after the integration one, and then the end-to-end test just checks that everything is fine.
Yeah, so the way that it works is we build the service, we do the unit and integration of the services build, and then it goes to a queue that, like when it's your turn, you go through the integration test, or the end-to-end test. And once that happens, it gets deployed to staging, and automatically, as soon as it hits staging, it'll get queued up to get deployed to prod. So really, once it passes the end-to-end tests, it's just a matter of time before it gets into prod, except for we pause to prod out of business hours, so that like, if there's a bunch of changes being made and whatnot, like no one's awake to really accompany them, in case like there's something that you're a little bit scared about, but like it's not something you can easily test. We want it to happen during business hours so that people are like at work monitoring it to some extent.
That's cool. Thanks.
Mm-hmm.
Do you have a tool to measure code coverage?
We don't have any measures for that. Generally, it's just when you push a new PR and you don't have tests, you'll get feedback that you need to have tests. I mean, we do catch instances of issues, but for the most part, like, we don't have anything to tell us. It's more just the goodwill of other engineers.
But you said when I see this is covered by an integration test, I don't need a unit test. But how do you know it's covered?
Look at the test, put a print statement. I mean, basically, when it's coverage of like a controller, you can hopefully your controller code is not huge, so you can see like, does it pass through this code execution path, and if it does, then you know you can take it out. And the way you test that, I don't know. I would just put a print statement there.
Okay, can you say all right, all right, all right?
All right, all right, all right.
It looks like Matthew McConaughey.
Missed that reference. I don't know what.
Anyway, so I think we're running slightly delayed. So we'll be back here at 17:36 for the slightly delayed. So we'll be back for the talk with Pierre. He's going to talk about all the cloud stuff. So I'll see you in 10 minutes. Thank you.